P. Madhav, lecturer in physics, in continuation of our video lectures. Today we will discuss about thermal properties of matter, Vsaq'S. The very first question is difference between heat and temperature. Now, difference between heat and temperature means, heat is a form of energy. First one, heat is in the form of energy. This is heat. This is temperature. Temperature is degree of hotness or coldness of the body. Degree of hotness or coldness of the body. Second one is heat is form of energy with degree of hotness or temperature. Heat is a cause. Temperature is effect. Temperature is effect. Okay, two main differences are there. And here, unit of heat is joule. This temperature unit is Kelvin. Kelvin or centigrade you can write. Centigrade scale. Centigrade you can write. Okay, centigrade. This is first question. And next we have the second question. Second question is, can a substance contract on heating? Can a substance contract on heating? So in this, can a substance contract on heating means, the answer is yes. First you should write yes. Yes. And next term, you can take water, type metal, cast iron metal. These are the examples for the substance which is contracts on heating. Okay. Next, third question. Third question is, why gaps are left? Why gaps are left between rails while laying railway track? Now in this, why gaps are left means, here the gaps are left because in summer what happens, there is a rise in temperature, the gaps are completed. In winter it contracts, get back. Okay. So to allow the expansion and contraction, in different seasons, the gap is left between two rails. That is the reason. Why gap is left means, in summer there is increase in temperature, thereby there is expansion. In winter there is a decrease in temperature, contraction. So to allow the expansion and contraction, gaps are left between two rails like this. Okay, this is the third question. And next question is, what are the units of specific gas constant? What are the units of specific gas constant? This specific gas constant means, here specific gas, smaller if you take joule per kg per Kelvin is the unit of specific gas constant. Okay. Now next question. Does a body radiate? Does a body radiate heat at 0 degrees Kelvin and at 0 degrees centigrade? No, at 0 degrees Kelvin body does not radiate heat, but at 0 degrees centigrade it radiates heat. So at 0 degrees Kelvin, the body does not radiate heat. But at 0 degrees centigrade, the body radiates heat. Okay, this is fifth question. Okay, now body does not radiate at 0 degrees Kelvin, but at 0 degrees the body radiates heat. Okay, the objective questions are tricky questions. While answering them, suppose if it is yes or no given, you should write first yes or no, then your own reasoning, like 1 or 2 lines you have to finish up the answer. And the third question is, state different modes of transmission of heat. State different modes of transmission of heat, and which of these modes require medium? Which of these modes require medium? Now there are 3 modes of transmission of heat, that is conduction, convection and radiation. Conduction and convection require medium, whereas radiation does not require medium. It can it radiates, because the earth receives heat from the sun. In between there is no medium, vacuum, but even then we are getting heat. So radiation does not require medium, whereas conduction, convection require medium. So you can write conduction, convection and radiation are the 3 modes of transmission of heat. You can write in sentence form. And conduction and convection require medium. Radiation does not require medium. This is the answer for this question. Okay. Now next we have another question like, what is thermal resistance of a conductor? What is thermal resistance of a conductor? On what factors does it depend? So while doing this thermal conductivity, we have Q is equal to Ka into theta 2 minus theta 1 into P by L. Okay. So here the thermal conductivity is given by R is equal to L by Ka. Thermal resistance Ke, this is the formula. Thermal resistance is given by L by Ka. So it depends on the It depends on the length and area of cross section of the conductor. It depends on the length and area of cross section. K is constant for a given value. Okay. It depends on length and area. Depends on the length and area of cross section of the conductor. Okay. This is the one. Easy one. And next one is, next question. State Newton's law of cooling. This is state Newton's law of cooling. Newton's law of cooling means, Newton's law of cooling means the rate of cooling is directly proportional to mean excess temperature. Mean excess temperature means what? Here dq by dt is proportional to theta 1 plus theta 2 by 2 minus theta s. Average temperature by theta s is the surrounding temperature. Suppose temperature reduced from theta 2 to theta 1. Okay, and then in a time interval from t seconds, theta s is the temperature of surroundings. Temperature of surroundings. Theta s is the temperature of surroundings. Theta s is called the temperature of surroundings. Theta 1, theta 2 means, suppose 60 to 40, it is decreasing. So 60 plus 40 by 2 you should take. Mean excess temperature is called. Mean excess temperature means average minus temperature of the surroundings. Surrounding temperature say 25. So you have to subtract average minus 25. That is called mean excess temperature. Okay. Average minus theta s. Okay. This is the answer for this question. And next, 10th question. State the conditions for which Newton's law of cooling is applicable. State the conditions under which Newton's law of cooling is applicable. So here there are three conditions by which, so here conduction is, the heat lost by conduction is negligible, but it is mainly by, heat loss is used only convection. Heat lost by conduction is negligible. Is negligible. Only it is due to convection. And there should be uniform distribution of heat. Second one is, there should be uniform distribution of heat. And the last one is, temperature of every the temperature of every part of the body should be same. Temperature of every part of the body should be same. Okay? These are things. Next continuation, like we have state means displacement law. State means displacement law. See, state means displacement law means here, this is the equation with the help of which we can find out the, if you know the wavelength of the emitted radiation, we can find out temperature. So wavelength of the emitted radiation is inversely proportional to absolute temperature, or lambda m into T is equal to constant. This is called Wien's constant. Lambda m into T is from B, like that we have constant, some constant, which is equal to 2.9 into 10 to the power of minus 3 meter Kelvin. This is called Wien's constant. So once if you know this Wien's constant value is 2.9 into 10 power of minus 3 meter Kelvin. If you know temperature, if you know wavelength, you can find temperature. Next, what is the specific heat of a gas? Next, what is the specific heat of a gas in isothermal change? B, adiabatic change. You know, C is equal to 1 by m dq by dt. Isothermal change means dt is 0. No? So A, first answer is 1 by 0 is infinity. In isothermal adiabatic change, dq 0. So C is equal to 0. Specific heat of a gas under adiabatic process is 0, under isothermal is infinity. Okay. Again, now we'll do questions in thermodynamics. Thermodynamic questions. Here the very first question. Define calorie. Define calorie. Define calorie and write the relation between calorie and mechanical equivalent of heat. Mechanical equivalent of heat. Now in this, what is calorie means? It is the amount of heat required to raise the temperature of 1 gram of water from 14.5 degrees centigrade to 15.5 degrees centigrade. That is called calorie. And 1 calorie is equal to 4.2 joules. 4.18 we call that, or 4.2 joules you can take. Okay. So here mechanical equivalent is work done needed to produce 1 calorie of heat is called as mechanical equivalent of heat. 1 calorie is equal to 4.2 joules. So mechanical equivalent of heat means it is the amount of work needed to produce 1 calorie of heat. 1 calorie of heat is called as mechanical equivalent of heat. Okay. Now next we have another question. This next second question. Second question is what thermodynamic variables can be explained with the help of first law of thermodynamics. First one is zeroth law. Next, first law of thermodynamics. So in this zeroth law gives explained about temperature concept. Temperature can be explained with the help of zeroth law. And the first law of thermodynamics explained about the concept of internal energy. First law explained about the internal energy. And zeroth law explain about the concept of temperature. Okay, this is the second question. Next, third question is here. Define state variables and equation of state. Define state variables. Define state variables and equation of state. Equation of state. See, state variables means what, you know? These describe the equilibrium state of a substance, pressure, volume, temperature, and mass can be taken as thermodynamic variables. And equation of state means the equations relating to this. P is equal to nRT is the equation of state. Example, P is equal to nRT. If you take that is the equation of state, the equation related to this thermodynamic state of variables like pressure, volume, and temperature, mass. Pressure, volume, temperature, and mass can be called as state variables. And the equations related to this, PV is equal to nRT. This is the equation of state. The equation related to this thermodynamic variables, we call it as equation of state. Now next, fourth question. In summer, when the wall of a cycle tube, wall of a cycle tube is opened, then the escaping air appears cool. Why? See, escaping air appears cool. Why? Because it is an adiabatic expansion. When a cycle tube is open, suddenly means sudden change is adiabatic expansion. So, because of this sudden expansion, it produces cooling effect. It is due to adiabatic expansion. You can write it is due to adiabatic expansion. Sudden means always remember it is adiabatic expansion and it produces cooling effect. Fourth question. Okay. This is the fourth question. Sudden change means adiabatic. Slow process means it is like isothermal. It is a quick process. It is adiabatic expansion. Next, why does the brake drum of an automobile gets heated while moving down at constant speed? Okay. Now here in this the work done against friction between the brake drum and brake shoe produces heat. Produces heat. Because of that, the brake drum is getting heated up. So the frictional force between the work done against friction between the brake drum and brake shoe produces heat. Therefore, it drum getting heated up. So answer you can write like this: the work done against friction between brake drum and brake shoe produces heat. So it is converted into heat also converted. Is converted into heat. Therefore, the brake drum is getting heated up. Therefore, the brake drum gets heated up. Therefore, brake drum gets heated. Very important question. Okay. A couple of times I have to be asking in exam. Okay, board exams. Next question. Next question is, if the thermos flask containing the liquid is shaken, then shaken vigorously, then what happens to its temperature? Now here, what happens when you are shaking the liquid inside the thermos flask? Here temperature increases because it is an isolated system. So therefore, what happens here? Internal energy increases, temperature increases. Okay, internal energy increases. Answer. Energy increases, therefore temperature increases. So derivative temperature increases. Thermal isolated system, so as you moving shaking that, intensity of the molecule increases. Next question. The coolant in a chemical, or nuclear plant, must have high specific heat. Why? Answer is, so why high specific heat substance means when lot of heat energy is liberated in chemical plants and nuclear plants. So thereby what happens? The substance which is kept there should absorb more heat, thereby the other parts of the plant remains at normal temperatures. That is the reason why you have to use specific. More specific heat means it absorbs more heat. Okay. So the answer is heat absorbed by direct, here Q is equal to MST, ms delta T. So heat absorbed is directly proportional to specific heat. So if it is having more heat means, more specific heat means, coolant with more specific heat absorbs more heat. Large amount of heat can be removed. So thereby it will be the prevented, so different parts of the plant can be kept cool or at normal temperature. Plants prevented from getting too hot, or it can be at normal temperature, or other parts of the plant will not get too hot. That is the reason. It absorbs more heat. More specific heat, more heat can be removed. More heat can be removed. More heat can be taken out. So other parts of the plant will not get too hot. It will be at normal temperature. Okay.